Welcome to this explainer. Following the script structure outlined in our source document, titled ENGV, we're zeroing in on May 7th. Now, on the surface, it's literally just another square on the calendar. But in the history of mathematics, it is an absolutely golden day. We're going to dive into how this seemingly ordinary date connects extraordinary minds across completely different eras, unlocking secrets that basically built the modern world we live in.
Looking at May 7th through the decades, our timeline hits 1954, 1963, 2007, and 2017. Let's see exactly what happened.
Okay, let's dive right in. Have you ever looked up at the night sky and wondered, how do we actually know where the stars are to steer a spaceship? I mean, how do astronomers thread the needle through millions of chaotic, constantly moving stars to calculate the perfect path for a rocket?
To find out, we rewind to Henri Mineur, a brilliant French astronomer who passed away on May 7, 1954.
You see, Mineur realized that you absolutely couldn't just guess where stars were going. You had to calculate their complex movements based on their exact distance from the galaxy's core. So he built these incredible early numerical calculation methods for deep space. He essentially took the wild, unpredictable chaos of the Milky Way and translated it into clear, reliable math. And because of his dedication to crunching those massive numbers, he laid down the tracks for space exploration long before rockets could actually reach those distances.
And here is the big takeaway. Every spaceship launched today relies on the cosmic math mapped out decades ago. We can literally navigate the stars today because Mineur learned how to calculate them on paper first. It's a real game changer.
Still on May 7th, but let's jump forward to 1963 to solve an explosive problem right here in our own atmosphere. Think about this for a second. When you're watching a massive, heavy rocket blast into the sky at supersonic speeds, why doesn't it just wobble out of control and crash under all that intense pressure?
Well, that mystery was solved by aerospace genius Theodore von Kármán, who left his permanent mark on May 7, 1963.
Before von Kármán, high-speed flight was incredibly unpredictable and, honestly, highly dangerous. The air would literally fight back, causing violent turbulence. But using complex math formulas, he calculated the invisible boundary layers of airflow. Basically, he mapped out exactly how the air hugs the metal of the plane. By understanding those layers, he gave us the precise equations needed to design aerodynamic shapes for safe supersonic flight.
It really proves a phenomenal point. The invisible air around us can literally be tamed by the power of mathematical equations. So, next time you're on a super smooth commercial flight, definitely thank aerospace math.
Same date, decades later. Now, we enter the digital age. Let's jump to May 7, 2007.
Here's a question for your daily life. How are your private messages and passwords kept completely secret on the internet? What exactly is keeping the hackers out when you log into your bank account?
For that incredible security, we owe a huge debt to mathematical pioneer Emma Lehmer, who passed away on May 7, 2007.
Lehmer actually worked night shifts programming the ENIAC. And remember, this wasn't some sleek laptop. It was one of the world's first massive, room-sized computers covered in wires and dials. Using this giant machine, she unlocked deep secrets of number theory, using early computer codes, specifically working with what are known as sieve methods. She essentially built mathematical filters to hunt down highly special prime numbers. And it turns out those specific prime numbers form the very foundation of modern digital encryption.
It is wild to think about. The secret codes protecting your digital life were born in the earliest days of computer math. Every private message you send is secretly locked up using the exact number theory she helped pioneer. One date, so many stories. Let's make our final jump to May 7, 2017, where math completely transforms artificial intelligence.
Have you ever wondered how a computer actually knows how to solve a puzzle or think through a complex shape? I mean, how does a machine fundamentally learn to reason?
That brings us to Wen-Tsun, a brilliant mathematician who passed away on May 7, 2017.
Wu did something truly astonishing. He translated complex geometric shapes into polynomial equations. In doing that, he basically taught computers to automatically prove math theorems. Instead of just acting as giant calculators crunching basic numbers, he gave them a language to understand geometry. He figured out how to mechanize math itself, allowing computers to essentially think through logic completely on their own.
His work beautifully illustrates a massive leap forward.
Teaching a computer to do math was literally the first step to teaching a computer to think. It was a critical stepping stone toward the entire AI revolution we're living through right now.
So, looking at our full timeline connecting 1954, 1963, 2007, and 2017, every single person we met in this explainer today, across completely different centuries and countries, fundamentally asked the exact same question.
They all wanted to know, what is the pattern hiding inside the chaos? They looked at the beautiful chaos of the stars, the turbulent wind, elusive prime numbers, and complex shapes. And because they refused to leave those mysteries unsolved, our world today has spaceflight, supersonic jets, unbreakable cybersecurity, and incredibly smart artificial intelligence.
Which leaves us with this final thought. As the calendar keeps turning, who will be the next great mind to change the world on May 7th? And more importantly, what mathematical mysteries are you going to solve to shape our future?